This is Chapter 4, Lesson 1, Midsegments of Triangles. Here's your warm-up. Please find the missing angles using algebra. Note that you should be using the sum of your interior angles are 180 degrees for the first three. And then the exterior angle is the sum of the remote interior angles. Here's our essential question. Make sure to write this down. How do you use coordinate geometry to find relationships within triangles? Our objectives. Remember, these are important to write down because at the end of the lesson, you want to be able to say whether or not you learned to identify parallel segments, specifically within a triangle, and to find lengths in a triangle. And our only vocabulary term here is midsegments of a triangle. It's a segment, so it's a piece of a line connecting the midpoints. So that's the halfway point of two sides of a triangle. So our first key concept is that if a segment joins, so it's a segment, joins the midpoints of two sides, so two sides are being joined of a triangle, then the segment is parallel. So segment is parallel to the third side and is half as long. D is the midpoint of CA. So here's our midpoint. And E is the midpoint of CB. Here's our midpoint. And remember that these lines tell us that these two segments are the same length. And these lines tell us the segments are the same length. So DE is parallel to AB, DE is parallel to AB, and DE is half. Remember, that's important. It's half the length of AB.
In this problem, you will identify parallel segments. What are the three pairs of parallel segments in triangle DEF? Remember, the triangle midsegment theorem states that if a segment joins the midpoints of two sides of a triangle, then the segment is parallel to the third side and is half as long as the third side. How do you identify a midsegment? Look for indications that the endpoints of a segment are the midpoints of two sides of the triangle. R is the midpoint of segment ED. And S is the midpoint of segment EF. So, segment RS is a midsegment of triangle DEF. By the triangle midsegment theorem, segment RS is parallel to segment DF. S is the midpoint of segment EF. And T is the midpoint of segment DF. So, segment ST is a midsegment of triangle DEF. By the triangle midsegment theorem, segment ST is parallel to segment ED. T is the midpoint of segment DF. And R is the midpoint of segment ED. So, segment TR is a midsegment of triangle DEF. By the triangle midsegment theorem, segment TR is parallel to segment FE. So segment RS is parallel to segment DF. Segment ST is parallel to segment ED, and segment TR is parallel to segment FE.
In triangle XYZ, A is the midpoint of XY, B is the midpoint of YZ, and C is the midpoint of ZX. What are the three pairs of parallel segments? It might help to draw a picture. Now we're going to look at being able to find the lengths of line segments when we're constructing midpoint segments.
In this problem, you will find lengths. In triangle QRS, point T, point U, and point B are midpoints. What is the length of segment TU, segment UB, and segment QR? Which relationship stated in the triangle midsegment theorem should you use? You are asked to find lengths, so use the relationship that refers to the lengths of a midsegment and the third side. Use the following relationship to write an equation about the length of each midsegment. The length of a midsegment equals 1/2 times the length of the third side of the triangle. First, find the length of segment TU. Use the triangle midsegment theorem. Segment TU is a midsegment parallel to side SR, so the length of segment TU is half the length of side SR. Substitute 40 for SR. Simplify by multiplying. Next, find the length of segment UB. Use the triangle midsegment theorem. Segment UB is a midsegment parallel to side QS, so the length of segment UB is half the length of side QS. Substitute 50 for QS. Simplify by multiplying. Then find the length of side QR. Use the triangle midsegment theorem. Side QR is parallel to midsegment TB, so the length of side QR is twice the length of segment TB. Substitute 30 for segment TB. Multiply each side of the equation by 2. Simplify. So the length of segment TU equals 20, the length of segment UB equals 25, and the length of segment QR equals 60.
In the figure at the right, AD equals 6, D equals 7.5. What is the length of segments DC, AC, EF, and AB? It may help to label your figure. And your ticket out the door. How is the length of a midsegment related to the length of the third side?